G'day. This is my mill. It's a Swedish Sajo universal. It's probably one of the smallest universal mills that you can find around the place. It's called a universal mill because the table here can swivel, which means you can cut helical gears and that sort of thing on. Today I'm going to be using it to cut some straight spur gears, and probably in later episodes I'll use it to cut helical gears and do a few other things which aren't common run-of-the-mill operations. The head of this comes off. There's a crane up the top here, and so the head swings over here, and it can be converted to a horizontal mill, and that's how I'll be using it for the gear cutting. The gear cutting process is pretty straightforward, but it does take a little bit of time to change the mill over in its configuration, so usually I do my gear cutting in batches. I've machined the blanks for those 5 gears, so I'll just be doing it on here with my dividing head and the mill, and we'll take you through that process. And here we are. The transformation is pretty much complete. So as you can see, the overarm has come out, got the horizontal spindle on there. Vertical head is now stashed on a bracket just round to this side, which you probably can't see. But other than that, I've now got a horizontal mill. So to make gears in a home workshop, typically use a thing called a dividing head. This is one of them. I've got a couple. And the way these work is that you've got a spindle where you mount the work. That's geared down to a shaft that goes through here. You've got a wheel, and they can have a variety of hole patterns, so that when you turn the wheel, the way you want to turn it, the charcoal there, or whatever you've got the work fixed to, is there. So you then use a table, and these are around on the net, but also in Machinery's Handbook and things like that, which for a 40:1 worm ratio, which is what's in here, it'll tell you, okay, to cut say 36 teeth, which is what we're about to do, you need the 18 tooth wheel, and you need to go 1 2/18 of a rotation to get that indexer. So of the dividing plates here, I've selected the one with the 18 teeth, and I've actually fitted it to the dividing head over here, which we're going to use. So this is the dividing head I'm going to be using today. I use this one mainly out of habit. The smaller one I use when I have to do something a bit complex, and so I need a small dividing head to sit on a rotary table or something like that. This one is actually what's called a universal dividing head. The difference between a universal and a semi-universal is basically this bit of gearing here. The universal, you can drive back through the shaft and do some strange things, which comes in handy for differential indexing and helical milling, things we'll talk about later. But the basic idea is that you put the plate on, you put on the sectors of the finger. There's usually a sliding clip that goes in there to hold that on, and then there's some form of handle which goes on, and there it is all set up. And so once again, if I want to rotate the chuck there, which isn't mounted on, I can rotate that. And so if the table says on the 18 hole thing 1 2/18, I set my fingers here, to cover 2/18, and it's worth noting, no, that's no good. It's worth noting that what you're actually, when it says 2/18, you're actually talking about the spaces. So for 2/18, I'm actually going to, this isn't set up right, but I'm actually going to go 1 space, 2 space. And that's that's basically how a dividing head will index round. So you get to a point, because a backface you always fit the same way, but you get to a point, you then lock the head, do your cut, go back to your starting point, index your head, lock again, and so on. So it's very repetitive, it's not terribly exciting, but that's the way a dividing head does its job. There are other ways of doing things. One is direct indexing. As you may be able to see, there's a whole range of holes around here. So if you're cutting 24 teeth, another option is just to rotate that round until that goes in a hole. Saves having to work out and count things here. Occasionally I do that, but not terribly often. So here are the gear blanks. They're set up on an arbor. The arbor is the bore of the blanks is sized very closely to the arbor, so they're a very good fit. The collar that's on the arbor here, which is pinned in place, is also quite a neat fit. And after I made the arbor up, I turned that down to size so I can indicate off that collar, rather than having to strip everything down. This piece here is just a spacer, and here are the blanks. I've got two of them ganged up together. I'm going to take those down to final diameter. I'm in a 4-jaw because I want to make sure that the axis of the mandrel, or hence the bore, is spot on with the outer diameter. So here are my two blanks, finished machined. I mounted in the 4-jaw. I've got an adapter which takes a cam lock fitting that I've made up for the dividing head, and so I'll take that direct from here to the dividing head, just recenter that because it moves just a smidge, and then I can cut some teeth. So it's important that the plane of the cutter, for want of a better term, goes through the axis of the work. Here I'm just using the old steel rule trick. When it's horizontal, it's good enough. You could probably do all sorts of things with indicators, but for what I do, it works. First cut made, and now we index round. Break, 1 and 2 turns. This is one of those moment of truth sort of events where you see whether your indexing has been right. So normally I'd have this powered, but because of the noise I won't, but as you can see it winds through quite nicely, doesn't seem to be offline, so I think we can say that we've got evenly spaced teeth. The next moment of truth, of course, is going to be to count them just to check that our indexing. So here are the two gears. They've been cut. I've cleaned them up a bit with the wire brush just to get any small burrs off, and put a keyway in, and they're all ready to basically go on to the screws. Have the keys fitted, the washers to hold them down, bolt, and we're done there. Some people get a bit worried about the straightness of the horizontal arbor and how it's cutting, but the way I set this up is I come down to my work surface. I very carefully feed on till I just scratch the surface. Then I know that the tallest tooth is actually is cutting. From there, I don't worry. I just feed down the appropriate amount and go from there, because once that tallest tooth gets blunt, the next tallest tooth is going to come in, and so on. So it's not really a big deal. People worry about their arbors. Oh, it's tooth thou out of straight or something like that, and that it really doesn't matter for doing this sort of thing. There might be highly critical things that it does, but then again, if you're using a horizontal cutter, it's probably the same logic is going to apply. So here's the result of the gear cutting. The 236 teeth gears are attached to a screw which raises and lowers the side pieces. These two 24 teeth gears are idler gears. They're sitting on a stepped plastic bush there. There's a metal tube down the middle so that they don't crush or bind. That's just an M6 screw holding that there. This 24 tooth gear is welded onto the shaft, it sits on a spigot like so, and that's good enough to act as a pivot for the raising and the lowering of the gears. The gears are arranged so that when the side pieces are at maximum upward travel, these two surfaces are flush. When it's maximum downward travel, the two rollers are basically touching, those two surfaces are flush. So that just provides a way of allowing this to move up and down while this gear stays stationary. And so that's why these gears are thicker than that gear. So if you've only got a mill with a vertical head, this is the other way that you can cut gears. Obviously you're limited by the diameter of the gear before you run out of table space, because you've got to offset the table, but it will work. There you go, a little bit of simple spur gear cutting, straight gear cutting. In another video we'll have a look at helical milling or helical gear cutting, and probably do a little bit on differential indexing as well. So hopefully the dividing head stuff will fall into place a bit more then too. So I hope that was at least interesting, and thanks to those who've inspired me and helped me along the way.